In this video, we will be talking about angle-angle-side congruence, which means that triangles can be proven congruent when two angles and a non-included side, so a side that's not between the two angles of one triangle, are congruent to two angles and a non-included side, or a side not between the two angles of a second triangle. So it looks something like this. If I have angle A and angle E, and then I have angle B and angle F, and then a side like CB, segment CB and segment DF, then I could say that these two triangles are congruent because of angle-angle-side. So if we take a look here, we have this picture which has some arrows on it to represent our given that AD is parallel, segment AD is parallel to segment BC. And then we're given that angle A is congruent to angle C. And that's all they tell us. And we're trying to prove that triangle DAB is congruent to triangle BCD. Okay? Cool. So, in order to do this, they already wrote in our givens for us. How nice of them. And then they said angle ADB, so ADB. So if we were to look here, my parallel lines continue this way. And if I were to use my transversal and cut through, notice this angle is super big, so I can't say anything about this angle. And if we notice over here, my transversal keeps going. And this angle is super big, so I can't say anything about that. But I can say that this angle right here and this angle right here are congruent because of alternate interior angles. And that's going to be one of our common, if we see parallel lines, one of our common responses is going to be, or one of our constant reasons is going to be alternate interior angles. We're going to use that a lot anytime we kind of see parallel lines. Okay, that's going to be one of our main ones. So if you have parallel lines, you should be looking for alternate interior angles. Okay? So if we keep going, now that I know that, well, if we look here, ADB and CBD are congruent, and we just determined why that is. The reason for that they're congruent is because I have parallel lines cut by a transversal, and therefore they're alternate interior angles, and alternate interior angles are congruent. Now the last thing we can see in our picture is that both triangles once again share a side, and if they share a side, we call this reflexive, which means that segment DB is congruent to segment DB because it's the same line, and we call this the reflexive property. Which means that now we see we have angle, angle, side. Notice the side's not between the two angles like it was in the previous video. And we also have angle, angle, side. So by angle, angle, side, triangle DAB is congruent to triangle BCD. Okay? Our next one, next example. Once again, no boxes, so you kind of have some freedom to do what you want, but let's take a look at what we have. We're given that angle S, and remember, angles with one letter just means that there's only one angle at that point, is congruent to angle U. Okay? So we're told that these two are congruent. Okay? And we're told that TR bisects angle SRU. Okay? So this big angle here is bisected, and if we remember, bisect splits an angle into two equal parts. So if it's bisecting, then we know that this angle, which is SRT, and this angle, which is URT, are going to be congruent because the line TR, the segment TR, splits them into two equal parts. We also can see that SRT and URT both have the same line in their triangle, segment in their triangle, so this guy is probably going to be, you guessed it, reflexive. Okay? So RT is probably going to be reflexive. Now, let's get to the proof. Now that I've labeled everything, I've analyzed everything, I think we can do the proof pretty easily now. So, angle S is going to be congruent to angle U, because we start with our first reason, which is given, typically. And then we have segment TR bisects angle SRU. So there is our first statement and reason. Now next up we need to say that these two angles are congruent because we determined they're congruent by the fact that there is a bisector. So we can say that angle SRT is congruent to angle URT. And why? Because that is the definition of a bisector. A bisector splits one angle into two equal parts. So now I have two congruent angles. And if we notice, based off our given, we have angle, angle. And so we either need the side in between to prove that they're congruent, or we need a side outside of these two angles. So we either need ST or RT. Well, we have RT because we know that RT, segment RT, is congruent to segment RT because it's the same line and it's in both triangles, so we could say reflexive property is the reason that those are congruent. And if we look now I have angle, angle, side. Well, if I have angle, angle, side, then I'm done. That proves that triangle SRT is congruent to triangle URT because of angle, angle, side. And that is how we do a proof from scratch.